Okay, guys, welcome back to yet another episode of DSA Python series, and today we will be talking about binary search. Okay, let's do that. Binary search. Um, yeah, all right. So let's start with the discussion. So, guys, let me tell you one thing. This is not a class. It's not a lecture. It's basically a discussion where I will be doing some method. Okay, I'll be writing some codes. You may advise me. Okay, there might be some error in the code, or you can advise me some new method in the code, right? That is what is expected in this discussion, right? So what do you mean by binary search? Yeah. So what is binary search? Okay, let me just tell you the classic definition of what this binary search is. So binary search, it's a searching algorithm used to find an element in a sorted array list. So the main thing here is the list or the array has to be sorted. Okay. So what is the idea of this binary search? Okay. So the idea is, let's say we want to find any number in an array. Okay, let's say this is the question given. Binary given an array of integer nums which is sorted in ascending order. Okay, this is sorted in ascending order, and an integer target. So you have a target, write a function to search target in nums. If target exists, then return its index, otherwise return -1. So the most brute force approach which we can do here is, we will just have a linear search. Let us do the searching through linear method, right? Okay, so I have this nums. Okay, so n is equal to len nums, right? And I will just start a for loop for I in range 0 to n. So I have this target, right? So what I'll do is, I'll just put an if condition. If nums of I is equal to target, then return I, right? I need to return the index, right? Otherwise return -1. Okay, this is the, I hope this works. Mm, target is 9. 9 is found. Expected is 4. So I have this sorted in ascending order and an integer target. Write a function set target in nums if target exists and return its index. Right. Otherwise, okay. So uh, it is asking to do the write an algorithm with log of n. Okay. So what is this test case? Target is 2. Okay. Can I do like this? If nums of I is not equal to target, then return -1. Return I. So this equals, then I'll just return I, else I'll just return this -1 in the end, right? I think this will work. Yeah. Now you can see here restrictions failed. Okay. So the implementation uses a linear scan for the loop, which results in order of n time complexity, violating the log n requirement. Okay. So what do we have to do is we actually have to do this through binary search, right? So we have to implement the binary search. So for implementing binary search, what is the idea? Instead of traversing through the whole array, you actually need to traverse only the half. Okay. So I'll tell you how you can do that. Okay. So so let's say my n is equal to length of nums, right? So this will be there. Okay. um just see here that we have an array of integer which is sorted. Okay, sorted, and I want to find this integer as the target. Okay, so let's do the dry run here. um, I want to find this target 9. Okay, so what I'll do is I'll just uh, divide this up to n, I mean n by 2. I'll just uh, do this iteration up to n by divided by 2. Okay, so for I in range 0 to n divided by 2, right? So let us count 1, 2, 3, 4, 5, and 6. Okay, so 6 divided by 2 is 3. So the value of I is 3, right? It means that it will take the elements up to 4, fourth element, right? So this will be 0th index, this will be first, this will be second, and this will be third. So 5. Okay, so what I'll do is I'll just try to locate where my this element is. Okay, all right. So if nums of I, okay, so what will be my I, nums of I? So what I'll consider is I'll just take two pointer. Okay, one pointer will be my left, or you can say lowest, and the other pointer will be my highest. And what I'll do is mm, I'll consider an iterative approach, and I will divide low and height divided by that will be the middle point. I will try to find the midpoint. Okay, and if that midpoint is um, like if the midpoint is equal to target, okay, then I'll return the mid. Else if that nums of midpoint, okay, is less than target, then I'll just shift my low and high. Okay, um, so let's try doing that. So in I will just define a function. Okay, so this is um, so it's okay. So what I'll do is I will just consider low. Okay, this will be equal to 0, and my high as in, so low will be my this index. So this is basically an index. Okay, and my high will be this, right? 12. Okay, so high will be is equal to n minus 1, right? And in any of the case I will just have low will always be lesser than high. Okay, because high will always be high and low will always be low, right? So what is my first condition while I uh, iterate is I will just say while low is less than high, right? And in that if mm, low plus high, right? And if it is divided by 2, okay, so basically I will just say my low plus high is equal to mid, right? Okay, so my low is 0th position and my high is at 0, 1, 2, 3, 4, 5th position. Okay, so 0 plus 5 is 5. Okay, so this is 5 divided by 2 will be 2 to the 4, 2, right? So remainder will not be counted here. So 0, 1 and 2. So 3 is coming. So the value of mid is coming 3 as in 2. Okay, so this is index. Okay, so mid is the index. Okay, so 2 indexes, nums of mid will be 3, right? So what I'll do is, if nums of mid is equal to target, right? So is it equal to target? No, it is less than target, right? So it is less than target. So if it is equal to target, then I'll return mid. And if it is less than target, then what will I do? That we will see. So I'll just return mid. Why I'm returning mid? Because I want this index. I want the index. Okay, so mid is my index. Low and highs are also my index. But if this mid index, nums of mid index is equal to target, then I'll return the mid, right? I'll return the mid. Elif, if nums of mid, okay, is less than target, okay, if it is less than target, okay, then what I'll do, just think about it. If my nums of mid is less than target, which in this case, yes, then what I'll do, I'll just put this low, right? What I'll do, I'll just put this low to somewhere in the right side, right? Okay, why I'll do that? Okay, if I put this low into some right hand side, I'll shift it in right hand side, then since it is lesser than, since this nums of mid is less than the target, I'll try to converge to the target, right? And one more thing is there, if nums of mid means here in this case it's coming 3, right? 0, 1, 2, yeah, 3. So this nums of mid is less than target. It means that all the elements on the left hand side of nums of mid uh, is of no use for me, right? Right, is of no use for me. So what I'll do is I'll just put my low as mid plus 1. Mid plus 1. I'll shift my this. Okay. Mid plus 1. Okay. So what I'll do, I'll just say low is equal to mid plus 1, right? Else high is equal to mid minus 1. Mid minus 1, right? It will go to that. Okay, why high is equal to mid minus 1? Because if my answer is coming, let's say my nums of mid is coming 12, okay, so if there are other elements also, then 12 and other elements to the right hand side is no use for me. So what I'll do is I'll just try to do mid plus 1. I'll just try to shift this in the left hand side, right? My high, I have to shift my high to left hand side, right? So that I can exclude those integers or array list on the right hand side of 12, right? So high is equal to mid minus 1, right? Up to this, I think. Okay. So my low plus high is equal to mid is equal to low plus high divided by, just say mid is equal to, okay, this is because I have to talk about mid, right? This is coming correct, but in this case, so in the end, I'll just return minus 1. If all these conditions uh, are failed, then I'll just return minus 1. Okay, so this is the answer. Okay, uh, this is accepted. So this is accepted, right? So this question is asked in various product-based companies such as Google, Amazon, Microsoft. Okay, Uber. It is also asked in Uber. Okay, so just try doing it, guys. It's an easy question. Okay, if you are doing it for the first time, then probably you might have to look into the logic, what logic we are using, right? That is how you can do this, right? Now let's do a question from, so given a sorted array and an integer x, okay, and an integer x. So array is sorted. Find the index of the largest element in the array. Okay, index, I want to find the index of the largest element that is less than or equal to x. Okay, that is less than or equal to. This element is called floor of x. If such an element does not exist, return minus 1. So in case of multiple occurrences, return the index of the last occurrence. Return the index of the last occurrence. So let's say my ARR is equal to 1, 2, 8, 10, 10, 12, 19. So x equals 5, I, this is the target. Okay. So what is my output? Output will be equal to 1. Why? Explanation is largest number less than or equal to 5 is 2 whose index is 1, right? So what is the largest number less than or equal to target? So find the index of the largest element in ARR that is less than or equal to x. Another input is 1, 2, 8, 10, 10, 12, 19. X is equal to 11. Okay. So largest number less than or equal to 11 is 10. But this 10 is occurring two times, whose indices are 3 and 4. So the index of last occurrence is 4. Okay. That is why the output is 4. So return the index of last occurrence. Hmm. Okay. Input array is this, x is equal to 0. No element less than or equal to 0 is found. So output is -1. Okay. So can we do this floor in sorted array? Okay. So whenever sorted array is given, it means that just try to think about binary search, because binary search is valid if and only if the array is sorted. All right. If and only if the array is sorted. So whenever some sorted array is given, just try to think on those lines whether I can use binary search, right? There must be some way where I can use the binary search method. So in binary search, what we are supposed to do, we have to consider one low and the another one is high. I have to consider a mid. I will divide low plus high divided by 2. Okay. So that I get only quotient, not the remainder. And that quotient will be the midpoint. Okay. And nums of mid, I have to look whether that nums of mid is less than or greater than, or all those things we have to do some research and all. So this is the basic of sorted array. What sorted array, I mean, what this is binary search. Okay. So this is the basic of binary search. You take low and high, you find out the mid, you compare the nums of mid with certain numbers, and then you go ahead, right? That is all we have to do here also. Okay. So all these so how you can implement binary search on this floor in a sorted array? What do you mean by floor? I have to find out the largest element in array that is less than or equal to my target, right? And I have to find the index of that largest element. Okay. How can I do that? So let us put this Python 3. Okay. Now we have this self. Okay. I'll just start writing the code. N is equal to len of nums first of all, right? Low is equal to 0, high is equal to n minus 1, right? Why I'm taking n minus 1? Because high is actually an index. Okay. So index starts from 0 and ends at n minus 1. That is why I'm taking n minus 1, right? Now for I in range 0 to n, mid is equal to low plus high divided by 2, right? At least this is known. Once sorted array is given, this is my standard thing which I have to do. Now what I'll do, if nums of mid. Okay. Now let's, now from here thinking begins. Okay. I want to find out the largest element that is less than or equal to x. Okay. So let us consider this case. My low is 1, my high is 19. So 19 plus 1 is 20. So 20 divided by 2 is 10. Okay. 10 is my index. Okay. So nums of I'm sorry, it's not an index, it is the number. Okay. So I have to take 0 plus 0, 1, 2, 3, 4, 5, 6. Okay. 0, 1, 2, 3, 4, 5, 6. Okay, so 6 is the highest, this high. The value of high will be 6 minus 1, that is 5, right? So low plus high divided by 2. Okay. So what is my high? High is 0, 1, 2, 3, 4, 5, 6. Okay. So 6 plus 0 divided by 2 is 3. Okay. So 3 means index, that is the value of mid. Okay. So 0, 1, 2 and 3. So nums of mid is 10. So what do I say? If nums of mid means 10, right? This the value is 10. Okay. Um, it is greater than 5, right? It is greater than 5. Target is 5. Okay. So if nums of mid is greater than 5, what I'll do? I'll do I'll shift my high to left side. So I'll do high is equal to mid minus 1. I'll shift that high is equal to mid minus 1. So in that case, what is happening? So in this case, so my mid is this. Okay. 0, 1, 2, 3. So mid minus 1 will be this one, right? 8. So my high will be here. Okay. At 8. 0, 1, 2, 2. Right. Now again, this will start else. Elif nums of mid is less than x. Instead of 5, I have to take x. What I'll do? Low is equal to mid plus 1. Right. I'll shift my low to the opposite side. Else, if nums of mid is equal to x, so if nums of mid becomes exactly equal to x, then the largest number less than or equal to 5 is 2. So what I'll do, I'll just try to return. So floor in sorted array is basically I want to try I want to see the upper bound, right? So here I'll just say instead of so if nums of mid is greater than target greater than x, then high is equal to mid minus 1. Integer find the index 0 based of the largest element in n, that is less than or equal to x, less than or equal to x, element is called the floor of x. Okay. Floor of x. That is if buzz hello buzzy z, how are you? So nums of mid, let us try. So if nums of mid is greater than x, so my nums of mid is greater than x means, let's say in this case my nums of mid is coming 10, which is actually greater than x. So what I'll do is um, should I do should I consider this as upper bound for the time being? If nums of mid is greater than x, then uh, before doing high equals mid plus 1, I will just assign for this instant, for temporary assignment, let's say my low is equal to this index, mid index only. Okay, so what will happen is I'll I'll save the value of mid in floor, and I will then just change the value of high to mid minus 1. else else that's it. It means that it will cover both equal to sign and less than or equal to sign, right? And low equals mid plus 1, it will become mid plus 1. I think this should work. Nums is not defined. What happened? Okay, here it is ARR. But still I have to complete this. I'll just return floor. Okay, expected is 1, output difference. Okay, I'll have to just do while low is should be less than high, then only it will, they should not cross each other. Okay, your output 3, expected output is 1. So I just need to do equals mode. So equals 0 here. Can we ask something from Yogi Bot? Fetching some help for you. It's it looks like you are on the right track with using binary search to find the floor of X. However, there are a couple of things to consider in your implementation. Initialization of floor. You initialize floor to n, which is out of bounds for the indices of the array. You might want to consider initialization like minus and not like minus. Okay, so let's make it -1. Handling the condition when ARR mid is less than or equal to X. In your current environment, ARR mid is less than or equal to X. You should not just move low to mid plus one. Instead, you should also update the floor variable to mid. If your should be less than is equal to mid plus one. I is equal to mid minus one. I think this will work. I'm so sorry. Hmm. Your output is one expected output. Comparison complete. Just submit it. Wrong answer. If ARR of mid is less than X, given a sorted array ARR and integer X, find the index 0 based of largest element in ARR that is less than or equal to X. The element is called floor of X. If such an element does not exist, return -1. Simple ARR mid is less than X. Is greater than X, then I should be equal to mid minus 1 and this and low should be equal to this. Done. Expected output is 3. Let's say I consider this as upper bound and my upper bound is this. Return upper bound. High. What is high? I'm sorry, this is high and this is UB. Okay. If ARR of mid is greater than X, then it is equal to mid. This should work, man. Okay, it looks like you are on the right track again. Condition of while you can live. Special stop is equal to high, which might not allow to check the last digit. Okay, if low is less than or equal to high. Okay, updating upper bound. You are setting a bit to mid when error mid between, but you also need to ensure that you are correctly updating mid is less than so last current of the float. Just give this to the chat GPT. But it is giving me error. So my binary search should keep moving right when it finds a valid candidate. Let's say my answer I'll take UBS minus 1 down while low is equal to high, mid is equal to if ARR of mid is less than or equal to X, UB is equal to 1, low is equal to else high is equal to mid minus 1. Yeah, you get marks only for the first correct solution. You can solve the problem without reading the full solution. Okay. Guys, this is the solution for uh, now we could solve this problem successfully. So basically, we are supposed to find see this upper bound. So we actually considered if ARR of mid is less than or equal to x, then we temporarily mm, stored our mid into my upper bound. Okay, and this and low will become equal to mid plus 1, right? Otherwise high will be equal to mid minus 1, right? In the end I'll return UV. Okay, so this is the perfect solution for the question. Okay, given sorted array ARR integer x, find the index. So element is called floor of x. So that element does not exist. I'll I'll return minus 1, right? So I have taken upper bound as minus 1. If I don't find this, I'll simply return minus 1, right? Otherwise, this code will execute, right? That is how uh, this will work. Okay. All right, guys. That's all for today. Tomorrow we will do some more questions on upper and lower bound. We'll search insert position. Okay. Uh, okay. So all these things. So basically, binary search we will be doing tomorrow, right? Okay. Other questions on binary search, right? So that's all for today, and I'll see you tomorrow, same time. Till then, bye bye and take care.